On Monday, an asteroid the size of a basketball court will pass between the Earth and the Moon. It will come 4 times closer to us than the Moon itself, close enough that amateur astronomers can watch it move across the sky with a backyard telescope. It will be traveling at over 35,000 miles per hour. And we found it 6 days ago. 6 days! That's how much warning we got. Not 6 months, not 6 years, 6 days. If this rock were aimed directly at Earth instead of passing by, 6 days is what we'd have had to prepare for an impact carrying the energy of a nuclear weapon. And here's the part that should sit with you long after this video ends. The only reason we found it at all is because a single telescope in Arizona happened to be pointing at the right patch of sky on the right night. But before we get to why that matters, let me tell you what happened the last time an asteroid this size actually hit. February 15, 2013, Chelyabinsk, Russia. 7:15 in the morning. People are driving to work, kids are in school, the sun is barely up, and then the sky splits open. A rock roughly 20 meters across, about the same size as 2026 JH2, entered Earth's atmosphere at 40,000 miles per hour. It didn't hit the ground, it didn't have to. 23 kilometers above the city, the pressure of the atmosphere crushed it. The asteroid exploded with the force of 30 Hiroshima bombs. A flash brighter than the sun lit up the sky. Dashcam footage shows people pulling over, shielding their eyes, unable to comprehend what they were looking at. Then the shockwave arrived. 30 seconds after the flash, a wall of compressed air slammed into the city. Windows shattered across a 100-mile radius. Doors blew off hinges. Factory roofs collapsed. The shockwave knocked people off their feet. Over 1,500 people were injured, most of them by flying glass. 6 buildings were seriously damaged. A zinc factory partially collapsed. And the only reason the casualties weren't in the thousands is geography. The asteroid entered at a shallow angle over a relatively low-density area. If it had come in 30 seconds earlier, or 15 degrees steeper, it would have detonated directly above the city center. Nobody saw it coming. Zero warning, zero preparation. The first anyone knew about the Chelyabinsk asteroid was the blinding flash above the skyline. Russia's missile defense systems didn't detect it. NASA didn't detect it. No telescope on Earth spotted it before it hit. A 20-meter rock carrying the energy of 500 kilotons of TNT arrived without a single second of advance notice. Now 13 years later, we have 2026 JH2. Same class of asteroid, same approximate size, somewhere between 15 and 35 meters across. The difference is that this time, we spotted it, barely. On May 10, 2026, the Mount Lemmon Survey, a telescope perched on a mountain north of Tucson, Arizona, detected a faint smudge of light moving against the background stars. Magnitude 21, that's roughly 4 million times fainter than what the human eye can see. A speck. Over the next 48 hours, 4 more observatories confirmed the object. They calculated its orbit, and what they found was this: an asteroid on a trajectory that would bring it within 91,000 kilometers of Earth on May 18th. That's less than a quarter of the distance to the Moon, closer than some of the satellites orbiting above your head right now, but far enough away to pose zero risk of impact. Let me be clear about something. This asteroid will not hit Earth. Its orbit is well understood. There is no danger. But the fact that it exists, and the fact that we found it only 8 days before closest approach, tells a story that is far more unsettling than the flyby itself. Here's why. The telescopes we rely on to find near-Earth asteroids are good, but they're not good enough. As of 2026, astronomers have cataloged roughly 35,000 near-Earth objects. The big ones, anything over a kilometer, we've found about 95% of them. An asteroid that size would cause global devastation. We'd almost certainly see it coming years in advance. That's the good news. The bad news is the middle zone. Asteroids between 20 meters and 140 meters, big enough to destroy a city, big enough to flatten a forest the size of a small European country, and we've found maybe 40% of them. 40%. That means more than half of the asteroids capable of causing catastrophic regional damage are still out there, invisible, untracked, unknown. And we know they're there because the math tells us they have to be. NASA estimates there are roughly 25,000 near-Earth asteroids in the 140-meter-plus category alone. Below that, the numbers explode. In the size range of 2026 JH2, 15 to 35 meters, There are an estimated 40 million objects orbiting near Earth. 40 million. We found a few thousand of them. The rest are ghosts. They're out there, they cross Earth's orbit, and we won't know about them until either a telescope catches a lucky glimpse or our atmosphere catches the asteroid itself. That's exactly what happened at Chelyabinsk, and it's almost exactly what happened with 2026 JH2. The only difference is luck. The Mount Lemmon telescope was scanning the right part of the sky. The asteroid was reflecting enough sunlight to register on the sensor. The automated software flagged it. A human analyst confirmed it. And we got 8 days of warning instead of 0. But here's the question nobody in the press coverage is asking. What if it had been approaching from the direction of the sun? Asteroids that approach from the sunward side are effectively invisible. Telescopes can't point at the sun. The glare blinds every optical instrument we have. The Chelyabinsk asteroid came from the sunward direction. That's why nobody saw it, and that's why NASA is building NEO-Surveyor, an infrared space telescope designed specifically to find the asteroids hiding in the sun's glare. It doesn't launch until 2028 at the earliest. Until then, there's a permanent blind spot between us and the sun, and any asteroid approaching from that direction arrives with 0 warning. No 6 days, no 6 hours, just a flash and a shockwave. Let's talk about what 2026 JH2 would actually do if it were on a collision course. At 35 meters, the upper end of its estimated size, an asteroid entering the atmosphere at its current velocity of roughly 56,000 kilometers per hour would release energy equivalent to about 3 megatons of TNT. That's 200 Hiroshima bombs. It wouldn't reach the ground intact. Like Chelyabinsk, the atmosphere would shatter it in an airburst. But the shock wave from 3 megatons detonating 15 to 20 kilometers above a populated area would shatter every window within 50 kilometers. The pressure wave would damage buildings across an area the size of a major metropolitan region. Injuries would be in the tens of thousands. If the burst happened above a dense urban center, New York, London, Tokyo, Mumbai, casualties could reach 6 figures. And at the lower end, 15 meters, the damage is still significant. 50 meters is Chelyabinsk territory. A bright flash, a shockwave, 1,500 injuries, factory roofs collapsing. Every window in a city shattering simultaneously at 7 in the morning while people are brushing their teeth, getting in their cars, walking their kids to school. A normal Tuesday that turns into a disaster in less than a minute. None of that will happen on Monday. Let me say that again. 2026 JH2 is not a threat. It will sail past Earth at a distance of 91,000 kilometers, and within days, it will be nothing more than a data point in a catalog of near-Earth objects. Most people will never know it passed by. But the reason this flyby matters is what it reveals about the gap between what we can see and what we can't. We found this asteroid by accident, 8 days before it arrived, using a single ground-based telescope in Arizona. If it had been 50% darker, if its surface absorbed more sunlight instead of reflecting it, it would have been too faint to detect. If it had approached from 20 degrees closer to the sun, the glare would have hidden it. If the Mount Lemmon Survey had been pointed at a different part of the sky that night, we'd be learning about 2026 JH2 from news anchors after it had already passed, not before. The system works when it works, but it only works part of the time, and when it doesn't work, you get Chelyabinsk. No warning, no preparation, just a bright light and a wall of broken glass. There are things being done. The Vera Rubin Observatory in Chile is coming online with the most powerful survey camera ever built, a 3 billion pixel detector that will scan the entire visible sky every 3 nights. It's expected to discover tens of thousands of new near-Earth objects in its first year alone. NEO-Surveyor, when it finally launches, will stare into the infrared and find the dark asteroids hiding in the sun's glare. And the DART mission proved in 2022 that we can change an asteroid's orbit if we spot it early enough. But early enough is the key phrase. DART needs years of lead time to be effective. Even a nuclear deflection, the last resort option, needs months. 6 days is not enough. 6 days is enough to panic, but not enough to act. And right now, for the category of asteroid that includes 2026 JH2, 6 days is better than what we usually get. On Monday night, 2026 JH2 will streak through the constellation Ursa Major, cross the celestial equator, and plunge into the southern sky. If you have a telescope in dark skies, you might be able to see it. A tiny dot drifting slowly against the stars, magnitude 11.5, visible proof that a rock the size of a basketball court is threading the gap between Earth and Moon at 35,000 miles per hour. A dot of reflected sunlight that, 8 days ago, nobody on this planet knew existed. You'll watch it, and it'll pass, and nothing will happen. And that's the point. Nothing happened this time. Nothing happened at Tunguska in 1908 because it exploded over an empty Siberian forest instead of over St. Petersburg, and that asteroid was 5 times larger than 2026 JH2. It flattened 2,000 square kilometers of trees. 80 million trees knocked down in a radial pattern like matchsticks pushed over by a giant hand. The explosion was heard 1,000 kilometers away. Seismic stations across Europe registered the impact. If Tunguska had happened 4 hours later, the rotation of the Earth would have placed St. Petersburg directly underneath the blast, a city of 2 million people in 1908. The history of the 20th century would have been rewritten by a rock the size of a football field. Nothing catastrophic happened at Chelyabinsk because the angle was shallow and the population density was low. But 40 million untracked asteroids are still out there. We've found a fraction of 1%. Every few years, one of them threads the needle between Earth and Moon like 2026 JH2 is about to do on Monday. The question isn't whether another Chelyabinsk will happen. It's whether the next one comes with 6 days of warning or none at all. If you had 6 days to prepare for an asteroid impact in your area, what would you actually do? I'm not talking about theory, I mean Monday. What's your first move? Tell me in the comments. Because 6 days is what we got this time, and next time we might get less.